Hey everybody, this lesson is going to get you ready for your upcoming Integrated Math 2 test on Unit 6, modules 14 and 15. So it's kind of a long review, so I just split it up into two. So here we go, you guys. So it says use the diagram below to find the missing angles and explain your reasoning. Okay, right here, there's a right angle right here, and since we have this straight line right there, then this side must be a right angle right there. So let's go ahead and put that in right there. Okay, and so what I'm going to do now is use the angle addition postulate, and I know that this angle plus this angle will equal the right angle of 90. So this has to be 40 right there, okay? And then also this 40 and this guy right here, these are called vertical angles. So this is going to be 40 over here also because of the vertical angles theorem right there. And then what I'm going to do is use this straight line on the bottom half. Straight lines are always 180. So if this is 40, then this guy over here has to be 140 right there, okay? Because linear pairs, they make up a line, and there are two angles that make up a line, so they add up to 180 right there, okay? All right, so here we're going to solve for x and y and z. So first of all, we got to do solve for x first. So by vertical angles theorem, this side equals this side. So let's go ahead and do that. And then we got a quadratic equation. Quadratic equations are when it's x squared. So we want it to be equal to 0. So we're going to subtract 35 on both sides and make it equal to 0. So we can factor that. Okay, so then we factor this. Two numbers that multiply that gets me negative 35, and those same two numbers that add to 2 are 7 times negative 5. So we'll go ahead and do that, and then once we get it factored, we can use what's called the zero product property. Set this factor equal to 0, set this factor equal to 0. So we get x plus 7 equals 0, and then minus 7, and then we get x minus 5 equals 0, and we get plus 5 plus 5. So when we do that, we get x equals negative 7 or 5. Now, originally, guys, I said we couldn't use negative 7. But if I plugged in negative 7 right here, negative 7 squared is positive 49. And then 2 times negative 7 would be a negative 14. And 49 minus 14 does equal 35. So this is actually a solution. So I only circled this one, but I think that one's going to be circled too, okay? Because they're both okay. They give us positive numbers right there. Originally, I crossed that off. So they're both correct answers right there. All right, so now that we know let's see. So I probably did this a different way. What did I do? Yeah. Okay. So what I did right here, you guys, this straight line. There's always several ways to do this. One straight lines are 180. So if that's 35, then I have to have this to be 145 to get me 180 on this straight line. And then we'll use the vertical angles theorem again and set 145 equal to 10z plus 5. Okay, and then so subtract 5 and then divide by 10, and so there's our three answers right there. Okay, all right, so here we go. So in the figure, we got parallel lines. Let's go ahead and mark those parallel lines right there. Okay, so mark them with arrows. So you're just training your brain to see that those lines are parallel. Okay, so I have all kinds of congruent angles and all kinds of supplementary angles. Okay, we have corresponding angles are congruent. Corresponding angles are, or let's say I slid this line X down on top of line Y. Corresponding angles would be the ones like 3 would slide right down on 11, 4 would slide right down on 12, 8 would go on 16, and 7 would go on 15. And if I slid these two lines together, 6 right here would slide over to 8, 1 would slide over to 3. Those are all corresponding angles, and they're equal because of the parallel lines. Also, we have these other things that are called alternate interior angles. These are all inside angles right here, and if one's on one side and one's on the other side, the alternate side, they're equal to each other. They're alternate interior angles. Now, my students sometimes think maybe these are alternate interior angles. Well, no, those are linear pairs. We talked about those a couple of weeks ago. Linear pairs makes up a straight line. They're 180 no matter what. But as long as we got parallel lines, then the alternate interior angles are equal. Okay, let's go. So if 5 equals 69, what's 10? Okay, we just talked about that. Okay, so 5 and 10 are alternate interior angles. So we just said it's equal to 69 degrees. Okay, it says state the postulate or theorem, so the alternate interior angles theorem. And I don't know if our book says postulate or theorem. Some books say postulate in one book and then they say a theorem in the other. So if you just say alternate interior angles are congruent, that's okay. All right, so the next one here, you guys, is 9 and 6. So let's look at 9 and 6. Okay, here's 9, here's 6. Those are alternate interior angles also, so they're congruent. So 6 must be 115. Okay, how about 12 and 8? I'm sorry, 12 and 7. Okay, 12 and 7. Let's see. Well, here's 12. Here's 7. Again, alternate interior angles. Now this picture is not drawn to scale. If this is 118 right here, this should be the 118 right there. But I'm just going along with our handout in our that our department has. So whatever this angle is, that's what this angle is, even though it's not drawn to scale. So it would also be 118 for the alternate interior angles right there. I bet they were thinking about 11, you guys. I'm sure they were thinking about 11. But anyways, these guys would be supplementary right here, 11 and 7. So I don't know. We're just following what they had in the book, okay? All right, so this one is 4 and 11. Okay, there is no name for 4 and 11, but what you can do is, I know 4 and 12 are corresponding angles, so whatever 4 is, then 12 is, and then these guys make up a linear pair. So there's other correct ways to do this, you guys. So I just slid 4 down on top of 12, so 12 would be 72. And then now we can look at the straight line, the linear pair. 11 and 12 make a linear pair, a straight line, so they must equal 180. So if we do that, we take the 72 off of the 180 and we get 108. Okay, all right, what about 4 and 14? Okay, now we're jumping lines and all that stuff. There's no magic name for them, but what you can do is, the trick on these is they're either congruent or supplementary. So if you look at angle 4, this looks like an acute angle right here. And if we look at angle 14, this looks like an obtuse angle. So they can't be congruent, so they must be supplementary. So the supplement of 114, we just take that away from the 180 and we get 66. Okay, so I know they're not congruent, so they must be the other one, the supplementary. Okay, and that's the trick. If you got parallel lines, then angles are either congruent or supplementary. Okay, they add up to 180. Okay, all right, so we get a groovy proof. Okay, and it says write a proof for the corresponding angles theorem. So we're going to prove that. And that's assuming that we know things like alternate interior angles already. So that's what we're going to do. Is here's some free points right there. If you don't know anything, at least put the given down, and you know your last reason, or your last statement, sorry, is your proof statement. Okay. This always goes in the given, the first part of the given. And this is always, that's our goal. So my goal is going to be that last statement. I don't know how many steps that is, but what I am going to do is somehow get angle 1 tied with angle 5. Yes, they're corresponding angles, but that's what we're trying to prove. But I can do this. 1 and 3 are congruent because they're vertical angles. Let's go ahead and do that, okay? And then what I can do is, we already know the alternate interior angles. I'm going to say 3 and 5 are congruent because of alternate interior angles with those parallel lines, okay? If you have parallel lines, then alternate interior angles are congruent. Now check this out, you guys. A little transitive. If you can see the Z sort of formation, 1 goes to 3, and then 3 picks up right here and goes to 5. So if you can see 1 goes to 3, and you go down here, 3 goes to 5. If you make that little zigzag, then I can say that this equals this, or it gets congruent by the transitive property right there. And that's what we're trying to prove. So that would have been statement 4. Okay, all right, so here, use the diagram to answer each. Okay, so let's see. So we give us angle 4. Angle 4 is right here. I'm going to float this 3x plus 5 right here, and then angle 5 is right here. These guys are same-sided interior angles. See how they're inside, interior, and they're on the same side? Same-sided interior angles are supplementary, so we're going to add those up to be 180. So 3x plus x is 4x, and then 5 plus 95 is 100. So subtract 100, we get 4x equals 80. and then divide by 4, we get x equals 20 right there. Okay, so x would have to be 20 to make those guys supplementary angles, to make those lines parallel. Okay, all right, so this one says if 3 is equal to, let's go look at 3. Okay, so if 3 is 4x plus 12, so this is 4x plus 12, and 7, okay, these guys are corresponding angles, and 7 is 80 minus x, what value must they be? So what we're going to do is corresponding angles, if they're equal to each other, then we can say these lines are parallel. So I'm going to set the 4x plus 12 equal to the 80 minus x right there. Okay, and then here I'm going to go plus x to get 5x. Here I'll go minus 12 to get 68, and that's okay, we get a fraction. Just leave it as an improper fraction. That's a good, groovy answer. As you get higher in math, they tend to leave them like that. So I know you guys want to get a decimal on that and get 13.6, I think. Anyways, but 68 fifths is a good answer. All right, so here, given that we got some equal pieces, so PA is congruent to PC, so that's this side right here. Okay, and then it says BA, here's BA, this side is equal to this side right here. So this must be a perpendicular bisector of the segment AC. Okay, not line AC, we can't bisect a line, but we can bisect this segment. So perpendicular means that that's going to be a right angle right there, okay? So with those markings right there, then we know it's the perpendicular bisector. So now, if 2 is equal to 38, and both of these guys together makes a right angle because it's perpendicular, then we take 38 away from 90 right there, and we get angle 1 to be, when we subtract, 52 degrees, okay? And then this one says if PA equals 10, so here's 10 right here, and PB equals 6, what's AC? Okay, so what I'm going to do is think, okay, I got this right triangle right here. I can find out AB using the Pythagorean theorem, okay? So x squared plus 6 squared equals 8 squared, and notice I'm letting this be x right here, and that's just this piece of the triangle, and then whatever that is, I'm going to double it to get me the whole length right here, because whatever this side is the same because they're congruent right there. Okay, so this is 36, this is 100. If we take away 36 from 100, we get 64, and what number squared equals 64? 8. 8 squared equals 64. It's a 6, 8, 10 right triangle. All right. So we're not done. It says find the length of AC. So if this is 8, then this is 8. So AC must be 8 plus 8, or 16. Okay, and 3 plus 4. Okay, what's 3 plus 4? Well, if that's a right angle, that's a right angle, that's a right angle, that's a right angle. So 3 plus 4 must equal 90 right there. Okay. All right, what else do we have? So determine the unknown angle measures of the quad. Okay, this sure looks like a trapezoid, and we haven't really studied trapezoids yet, so we don't know if it is or not, but what we do know is a quadrilateral has 4 sides, so we do n minus 2 times 180. Here it's 4 minus 2 times 180. Now tell us what all the angles add up to, which is 720. So now we're just going to add up all 4 of these angles. So x plus 2x plus 3x plus 4x equals this 720, because that's what they all add up to. Okay, so we solve for x and we get x equals 72. It says find all the angles in there. So if this is 72, then this is 2 times 72, 3 times 72, and 4 times 72. So we get those 4 angle measures right there. Okay, let's keep going. Okay, so find the value of x here. Okay, so here, you guys, this is an exterior angle of a triangle, and the theorem says this exterior angle equals the sum of these 2 remote interior angles. So if we set that equation up, x squared plus this angle right here, so I'm going to go back up here, this angle plus this angle equals this angle right here. Okay, all right, now we got a quadratic. We want quadratics because it's a squared. We want quadratics equal to 0. So we'll subtract 134 on both sides, and 14 minus 134 is a negative 120. And then factors of negative 120 that add to 7. I'm already thinking, let's see, 12 and 10 aren't going to work. How about 12 and 5? No, that's not going to work either. I think I made a mistake on that. Let's see. That's only 60. So Oh, what is that one? Let's see, 12. Let's go, how about 20 and 5? No. 15 and 8. That's it. 15 times 8. That is my big mistake right there. This should be a 15 and this should be an 8 right here. So sorry about that, you guys. So I was doing this late last night. Sorry. So the 8 times 15 would work. And then so I set those equal to 0. So when I set these guys equal to 0 right here, I'm going to get negative 8 with this one and positive 15 with this one right here. Okay, and then we can't have negative 8, so I'm going to take that out right there. And let me fix that here. So, sorry, it just takes me a second. So x plus, this is going to be 8, and this will be minus 15. And then we set those equal to 0. Sorry. And then, so here I get negative 8, here I get a positive 15, and then that's what so we can't have negative 8 for an angle right there, because that'd make this a negative angle. So our answer is x equals 15. So anyways, that's what that would be. So instead of, that should be, anyways, you guys get the picture, okay? So it's 15, okay? Sorry about that. All right, anyways, let's keep going. So the measure of 13 angles of a 14 gone add up to 2014. Okay, remember, n minus 2 times 180 tells us what all of them add up to. So here we can do 14 minus 2 times 180. That'll tell us what all of them add up to, and they add up to 2160. So if 13 of them adds up to 2014, then the 14th one, we'll just let it be x. Okay, the 14th one, not the 13th one. Golly, full of mistakes, and I don't find them until I start doing the videos. Okay, anyway, so subtract, we're going to subtract 2014 from both sides. So when we subtract 2014, we still get that 14th angle, sorry, to be 146 degrees, all right? All right, yeah, and even us teachers make mistakes. We're human too, make them all the time. All right, so find the measure of angle KMJ. So let's go look at KMJ given everything else. Okay, so here's KMJ. So we're looking for this angle right here. All right, now they did tell us that KMJ is also congruent to NKM. So NKM, all right, I can find that angle no problem right there by doing 180 in a triangle. Let's do that real quick, okay? So if we do that, we get that top angle right there to be 41 degrees. I don't know where did I get 44. Golly, so that's what our answer is 44 degrees, not 41, 44. Boy, loaded with mistakes this morning. It's 6 o'clock in the morning here for me. We're on the coronavirus shutdown. It's kind of a weird feeling. Gosh. Anyway, so I'm doing teaching from a distance here. All right. So order the line segments from shortest to longest. Okay. So remember the theorem goes the bigger angle is opposite the bigger side. Okay. So right here, you guys, I got two angles in a triangle, so I got this third angle by taking it away from 180. So this is 57. Now I don't know what these lengths actually are, but I'm just going to randomly assign them numbers. Remember, the bigger angle is opposite the bigger side, the smaller angle is opposite the smaller side, and the medium angle is opposite the medium side. So just assign any numbers just to make it a real problem. It's so vague without numbers there. So just assign numbers. You can assign any of them. I assigned 3, 5, and 7. I just know that's the smallest angle, so opposite must be the smallest side. I could have made this any length right there. And then this is the medium angle, so this is the medium side. So make this side bigger than that side. I don't know what they are. I'm just putting some real numbers in there. And then this is the biggest angle, so this is the biggest side. So 7's bigger than 5, and 5's bigger than 3. Okay, now I'm going to use that for this triangle right here. Okay, so 58, 63, and how much more to get 180 in that triangle? So if we do that, we find out that that missing angle is 59 degrees. Okay, now with these random numbers that we put, we're going to use this 7 right here and recognize, okay, this is the smallest angle in this triangle, so 7 must be the smallest side. So 59 is the next smallest angle, so this must be the next smallest side. So I just assigned some other numbers and referencing off of that 7 right there, and I just made them 9 and 10. You can make them 8 and 9, or you can even make them, decimals. Just make sure that this is the smallest angle, so this is the smallest side. This is the medium angle, so this is the medium side. And this is the biggest angle, so this is the biggest side. Now I'm going to use this 10 right here with this triangle. Let's get this angle first, 180. So we're going to do 180 inside of there. Okay, and we get that final angle to be 52. Okay, and then 52 is the smallest angle in this triangle, so this side that we have randomly assigned as 10 is the smallest side. Okay, this is the next biggest angle, so this must be the next biggest side, and this is the biggest, this must be the biggest side. Okay, so given all those lengths right there, now we can order these guys from smallest to biggest. Okay, so shortest to longest, or smallest to biggest. This one's the smallest side, RS, and then this is the next smallest side, so ST, and then TR. All right, and then just keep going around. Okay, so I get that right there. Okay, with all those imaginary red numbers right there. All right, almost done with this guy, and we'll move on to the next one. Okay, see you in a bit.